manner. So the above problem can be solved by applying KVL in an anti-clockwise direction. So how do we do that? It's a solution now. So now we now consider loop A, B, E, and F. Let's say this is F and F, and apply KVL in anti-clockwise direction. So having done that, we're considering this loop here, this A, B, A, and F. So how do we go about it? Let's start from 6. Remember, we said when we're moving from a positive side to a negative side, we're experiencing a drop. But when we're going from the negative side to the positive side, we're experiencing a rise. So in an anti-clockwise manner, we're going this direction. So what are we experiencing? We're experiencing a rise. So it will be 6I1, because the current I1 is acting upon this resistor. 6I1 plus 5I. 5I, the current I is acting on it. It's going in a positive direction. That's rise from negative to positive. 5I, because I is acting upon it, minus, we're going 100 now, from positive to negative, drop, minus 100. We say we represent a rise with positive, a drop with negative. Remember that goes to 0. So remember, I is equals to I1 plus I2. In our first class, we stated that. So what do we now have? We now have 6I1 plus 5I, which is I1 plus I2 minus 100 is equal to 0. So now what do we have? We have 6I1 plus 5I1 plus 5I2 minus 100 is equals to 0. So 6I1 plus 5I1 plus 5I2 is equal to 100. 100 goes to the other side. We have that. So that's what we have now. Let's call this equation 1. So let's now consider, this is our first case for the first loop. For the second loop, we'll now consider loop B, C, D, E, and apply KVL in a anti-clockwise direction. So, but remember, this question, we were asked to find the branch current. We were asked to find the branch current. And what? We were asked to find the branch voltage. But since we have solved for the branch current and the branch voltage in our previous class, in this class I will just solve for the branch current, because the procedure is still the same, but I would just like to show you how it is solved in an anti-clockwise direction. For this class, I will just solve the branch current, and then I will solve for the branch voltages. So let's now go further. Applying KVL in an anti-clockwise direction in the second loop, we would have what? We would have, let's start. We would have, let's start from the side 8, from minus to a positive side. That's rise, so we have positive 8 I. What's the current acting on it? I2 is flowing in this direction. 8I2, 8I2 plus. We have rise here. Also have rise here, 10 I2, 10I2. But remember here, you can also say this is 11I1 plus 5I2 is equal to 100. So 10I2, let's continue, minus 6 is a drop from positive to negative, 6I1, because I1 current is acting on it, is equal to 0. So here we have 18I2 minus 6I1 is equals to 0. So I have 18I2 is equal to 6I1. So I1 now is equal to what? Is equal to 18 all over 6 I2. So I1 is equal to what? 3I2. This is our equation 2. So if you can compare this with our initial way of solving it in clockwise direction, you would see that we are now having almost the same values, rather the same values in I1 and in equation 1 and equation 2. So let's now continue. Equation 1 and equation 2, as you can see, they are identical to our answer when we now use it in anti-clockwise direction. It's now identical to that of one we solve in clockwise direction. Substitute equation 2 and 2, 1. What do we get? We have 6. In equation 1, we had 6I1 plus what? Plus 5. 6I1 plus what? 5 I1 plus 5 I2 is equals to 100. Or rather, we can say this also is I1 plus 5 I2 is equals to 100. So 11 I1 multiplied by what was our I2? Well, out was the equation for I1. We said I1 was equal to 3I2. So we'll now say here we have 3I2 plus what? 3I2 plus 5I2 is equal to 100. So multiplying this, we would have 33I2, am I right, plus 5I2 is equal to 100. We would have 38I2 is equals to 100 of I2 is equals to 100 over 38. Here we have I2 is equal to 2.63 ounce. So as you can see, our answer is still the same with that which we solved using a clockwise direction. So having done that, remember this was our answer, first answer. And this was our first answer. So now substitute I2 into the equation. I1 is equals to 3I2. Doing that, we would have I1 is equal to 3, open bracket 2.63 amps. As I1 is equal to what? I1 now be equal to 7.89 amps. So having done that, remember capital I is equal to I1 plus I2. So I now, let's divide it. I now is equal to 7.89 plus 2.63 capital I. So I now is equal to what? 10.52 amps. So this is our branch current. We are going in a clockwise direction to solve this. Here we have I1, we have 10 ohms resistor, we have 15 ohms, here we have 25 volts, here 20 ohms resistor, here 5 ohms, and here we have 10 volts. So let's say this is loop 1, this is loop 2. For loop 1, let's now say consider A, B, E, F, A, and apply KVL in clockwise. This is just an abbreviation for a clockwise direction. So how do we go about it? So let's start here from 10 volts. Going up, we have a rise. So we have positive 10 minus. Here we have a drop at 10 ohms minus 10 I1 because I1 current is acting on it. Minus what? Minus what? Always remember here minus 25 ohms, and I forgot here we have I1 minus I2 current. So minus 25 is a drop, 25 open bracket I1 plus I2. Let me say plus here, plus I2 minus what else? 5 ohms here is a drop, minus 5 I1 with an I1 current acting on it is all equal to 0. So what do we get? We have 10 minus 10 I1 minus 25 I1 plus 25 I2 minus 5 I1 is equal to 0. Here we have 10 of 10 minus 10 I1 minus 25 I1 minus 5 I1 by rearranging plus 25 I2 is equal to 0. So here we all have the like times in one places. So we would have what? 10 I1, 25 I1, and minus 5 I1 will give us 10 minus 40 I1 minus 10 minus 40 I1. Am I correct? Am I correct? This by this here will be minus. The negative side will be affected. The negative sign will affect it, minus 25 I2. Am I correct? Is equal to 0. So we would have here, let's now take it to the other side. We'll have 10 is equal to 40 I1 plus 25 I2, or 40 I1 plus 25 I2 is equal to 10. Let's call this our equation 1. We will now go for the second loop. Let's now say consider loop 2. which is B, C, D, E, B, and apply KVL in a clockwise direction. Remember this example, we're looking at a clockwise direction. So having done that, if you can look at our diagram, you would see that we are going. Now let's start with the voltage source. No, let's just go from let's start moving from B towards C. Since we're going a clockwise direction, let's move from point B to C. You would see we would have it will have a rise. We'll have 15 I2. Okay, you see we have 15 I2 there. Let's move from B to C. You see we'll have 15 I2 because I2 is acting on it, minus, looking at that voltage source would be a drop, minus 25, plus going down you would have a rise at that resistor, 20 ohms, 20 I2, because I2 was acting on it as it flows from E to D to point C. Then you would have what else again, plus going up 25, and you remember we have I1 plus I2 now all equal to 0. So having done that, you know that we have 15 I2 minus 25 plus 20 I2 plus 25 I1 plus 25 I2 equal to 0. Having done that, you know that we have here, by collecting our like terms, we would have say 25 I1 here plus 15 I2 plus 20 I2 plus 25 I2 minus 25 is equal to 0. So we have 25 I1 plus 15 plus 20, we have 35, plus 25, we have 60. 60 I2 minus 25 is equal to 0. So having done that, say 25 I1 plus 60 I2 is equal to, let's take 25 to the other side, 25. When it crosses the equality sign, it becomes word positive. So let's say this is our equation 2. So let's now solve for, let's solve equation 1 and 2 and find I2. How do we do that? So we would say, remember from 40 equation 1, 40 I1 plus 25 I2 is equal to 10. So we can make I the subject, I1 the subject. Now we would have 40, we would have what? 40 I1 is equal to 10 minus 25 I2. So we would have I1 is equal to 10 minus 25 I2 all over 40. Am I right? By doing this, we would have I1 is equal to, when you divide it, we would have, let's put it this way, 10 over 40 and 40 over 25 I2 over 40. So we have I1 is equal to 0.25 minus 0.625 I2. Let's say this is equation 3. Hope you understand it, what I'm doing here. So let's now substitute this. Let's now say substitute equation 3 into equation 2. Equation 2 was what? Equation 2 was 25 I1, just for remembrance, I1 plus 60 I2 was equals to 25. This was our equation 2. So substituting this into that equation, we would have 25 open bracket 0.25 minus 0.625 I2 plus 60 I2 is equal to 25. I hope you can concur with me. So multiplying this, we would have 6.25 minus 15.625 I2, am I correct? Plus 60 I2 is equal to 25. So having done that, we would what? We would sum them up. So what we have here, we would have 6.25 minus what? Minus, when we add them up together, we would have 44.375 I2 is equal to 25. Let's now take this to the other side. We would have what? We would have, this will be positive because when you add it to this, it will be positive. This will be 44.375 I2 is equal to 25 minus 6.25. So 44.375 I2 is equal to what? Is equal to 18.75. So let's divide through the C by 44.375. 2 is equals to 18.75 all over 44.375. So I2 is equal to 0.4225 ounce. So what can we say now? We can say we were looking for the current flowing across 15 ohms resistor. So I2, if you can see from the diagram, if you can go back, I2, just go back to the diagram or to the circuit, you will see that I2 was flowing from E to D to C and back to 15 ohms. So you can see I2 was flowing into 15 ohms. So we're asked to find the current that was flowing through the 15 ohms resistor. 15 ohms resistor. Hence, the current in the branch, or let's say the branch current, just here, the branch current. Let's say the branch current in 15 ohms is 0.4225 amps. So that's that for that example. So we would look into another example. So how do we do that? Let's now say solution. By considering loop A, B, D, A and applying KCL and applying KVL, KVL in clockwise direction. Let me just abbreviate it in a clockwise direction. If you see loop A B, D, and A in a clockwise direction this way, we would have what? We would have, let's start from 12, which is a drop we would have, and the current, what? There's a current here acting on it. There should be a current here going upwardly. This current is called I, acting on, so it's acting on this particular branch because it comes towards this branch I, still coming towards this branch I. So it will be minus what? Right to drop. It's a drop because it's going from positive to negative. Minus 12 I1 minus 3 is also a drop with the current I2 acting on it, plus 40, our voltage source is also a rise. This goes to 0. Is equal to 0. Am I correct? Am I correct? Yes. So we can now say, we can also say that this can also be written as what? 12I1 plus 3I2 plus 3I2 is equal to 40. Am I correct? Just check it out. It's correct. So let's now consider loop. This is the first loop. That's the first loop. Let's now consider the second loop, which we say is our second loop. Let's say B, C, D, B, C, D, and B. This should be our second loop. Let's consider this as our second loop. Let's call it B, C, D, B, and apply KCL in clockwise direction. So what we would have, let's start from here. B, from B to C, would have the drop minus 8. What's the current on the acting on it? I1 minus I2. Am I correct? Minus what else? 4 is a drop, the resistor, 4 ohms. Open bracket, I1 minus I2 plus I3. That's the current acting on it. I3 is all. No, we have another resistor, which is a rise 3 ohms with the current I2 acting on it equal to 0. So here we would have minus 8I1 plus 8I2 minus 4I1 plus 4I2. This is plus 4I2 minus 4I3 plus 3I2 is equal to 0. Let's say this is equation 1. So here we would have minus 8I1 minus 4I1 plus 8I2 minus 4 plus 4I2 plus 4I2 plus 3I2 minus 4I3 is equal to 0. And lastly, we would have what? Have minus 12I1 minus 12I1 plus 15. If you collect it like times, 15I2 minus 4I3 is all equal to 0. You can say this is our equation 2. Third loop, which is what? Which is A, B, C, A. So now, what do we do considering that loop? I will start with 12. We would have minus 12I1 from bracket 8. Remember, I1 minus I2 was the current acting upon this. Then plus 5I3 actually was acting upon the resistor 5 ohms is all equal to 0. So here we have minus 12I1 minus 8I1 and plus 8I2. This is plus 8I2 plus 8I2 plus 5I3 is equals to 0. Here we would have minus 20I1 plus 8I2 plus 5I3 is equal to 0. So this is our equation 3. So let's solve. equation 2 and 3 now, and 3 to cancel out I3. How do we do that? Let's multiply equation 2 by 5. Doing that, we would have multiply equation 2 by 5, multiply it and see, you would have 60 I1 minus 60 I1 plus 75 I2 minus 20 I3 is equal to 0. Secondly, we would say multiply equation 3 by 4. I think multiplying it by 4 would give us what we're looking for, of minus 80 I1 plus 32 I2 plus 07, no, not 107, 20 I3 is equal to 0. So let's add this up and see our result. By adding it, this and this would go. So we would have minus 140 minus 140 I1 plus 107 I2 is equal to 0. Let's call this our equation 4. Say, let's solve equation 4 and 1 to find I1 and I2. Our equation 1 was 12 I1 plus 3 I2 is equal to 40. Equation 2 was minus 40. Equation 4 rather, 140 I1 plus 107 I2 equal to 0. So let's say multiply. This is equation 1. Remember, this is equation 4. Multiply equation 1 by 107 so that we would cancel it out. 107. Doing that, we would have what? 1, 2, 8, 4, I1 plus 3, 2, 1 I2 is equal to 4, 2, 8, 0. So secondly, we would multiply equation 4 by 3. 3 by this by this. So we'll have minus 4, 20 I1 plus 3, 2, 1 I2 is equal to 0. So you see, this and this now will cancel out. What do we have left? We would have 71704 I1 plus 0 is equal to 4280. This means we have 1704 I1 is equal to 4280. So we're now subtracting here, remember? So having done that, what do we have left? We would have I1 is equal to 4280 all over 1704. I1 will be equal to 2.51 ounce. That's our answer. So we got I1. Sorry about that. Equation 4 was what? Minus 140 I1 plus 107 I2 equal to 0. So 140 multiplied by 2.51 plus 107 I2 is equal to 0. Here we would have minus 351.4 plus 107 I2 equal to 0. Here we would have 107 I2 is equal to 351.4 I2 is equal to 351.4 over 107 I2 is equal to 3.28 amps. So the current, remember, the current across current I across 8 ohms resistor is equal to I1 minus I2. So I now will be equal to, what is I1? We obtained I1 as 2.51 minus 3.28. So I now will be equal to 0 minus 0 minus 0.77 amps. So that will be the current flowing across our 8 ohms resistor. So thank you for watching our class today. Please, if you haven't subscribed, please subscribe and stay tuned.